Everyone, my name is Grecia and I am the program manager for the digital community at Women Who Code. Today, Tanusree McCabe, Senior Distinguished Engineer at Capital One, will present us the talk Architecting Resiliency, Recovery, and Reliability. Welcome, Tanu, and thank you so much for being here today.
Thank you. All right, so as mentioned, my name is Tanu. I'm currently with Capital One Architecture Strategy team. And one of the initiatives that's very much on our minds is around resiliency, recovery, and reliability. And the reason for that, why is that important, I'll cover in just a moment. And in this talk, we'll also delve a bit deeper in what resiliency, recovery, and reliability means to us and how we use those things to actually design cloud-based systems. So why is it important? It's important because the cost of failure is quite high. And we are all in on Amazon Web Services, and AWS enables users with cloud technologies to meet their different resiliency, recovery, and reliability goals. It's also worth noting that AWS has a well-architected framework, and resiliency, recovery, and reliability fall into two of the 5 pillars that they have in that framework called operational excellence and reliability. So at Capital One, we care very much about our customer experience, whether that customer is an external customer using our services or an internal associate using internal services. Either way, we want our systems and applications to be very highly resilient, recoverable, and highly reliable for a good experience. So this is how we define certain pillars of site reliability engineering, or SRE. We define resiliency as the ability to avoid or mitigate impact from an adverse event. What that means is we do understand that failures will happen despite our best efforts to prevent them. So knowing that a failure can happen in our system or in the ecosystem that supports that system, we want our system to be architected so that it can quickly mitigate the impact of that failure. Recovery is key for resiliency, kind of goes hand in hand, and that's the ability to restore service when failure occurs. What we're basically saying is we want things to be highly available, and if failure does happen, which it inevitably will, we want to be able to restore the service and experience as quickly as possible to limit the exposure of that particular adverse event. Reliability is the ability for a service to provide its expected function. To give you an example, if a system fails and recovers very quickly, that's a good thing. But if it fails every day and still recovers quickly every day, that's still not exactly what we're looking for in terms of reliability. A highly reliable system will provide expected functions over a much longer period of time. Together, these 3 pillars intersect into what we call stability. So really, our aim is we want to have very stable systems. And these stable systems are architected to adhere to business-defined goals. For example, recovery time objective, recovery point objective, service level objectives. These are all metrics or measures that help us quantify the goals of stability for each system. Now, how do we put this together to define a particular system? This is a generic system in AWS. And what you can see here is at the top, we have an EC2 instance of server, and it's communicating to a database. And it's placed in one availability zone inside a VPC. That's all well and good, but when we look at it through the resiliency lens, there are certain architectural considerations that matter. For example, scaling. So as demand changes for this particular system, can the application scale horizontally up or down? The key word here is horizontally. It is possible to scale in place by changing out service sizes and things like that. But what we're really looking for is scaling horizontally, meaning adding more capacity to the fleet to be able to handle increases in demand. And from a cost efficiency perspective, we want to be able to scale down as well so that we have the appropriate amount of capacity to serve our demand. Redundancy is another key consideration for resiliency. It's a common technique used to increase availability. What we mean by that is if we have redundancy built into our system, if one part of the system fails, the other part should still be available and be able to serve our customers. And finally, capacity. I mentioned capacity specifically for the servers already. In this sense, capacity is also expanded to talk about the network. For example, if we want to add more servers and those servers take IP addresses, then inside our VPC, inside the subnets that those servers are associated, we need to make sure the subnets have enough free IP space. In addition, sometimes our applications are directly calling AWS APIs. We want to make sure service quotas are set and managed so that we don't experience any throttling. When we put that together, we now see that our simple application is extended to be highly available. We have used in this illustration the auto-scaling service to illustrate how EC2 can be horizontally scaled. In addition, the RDS is now configured as a multi-AZ highly available configuration where there's a primary and there are alternates with data replication happening behind the scenes. This gives us redundancy, which we talked about as one of the key considerations. In order to route the traffic properly, we've now also added a load balancer. So that is helpful because now we know that our system should be highly available. As mentioned though, if a failure happens, we need to also look at recovery. How are we going to architect for recovery and make sure that that system can swiftly recover from that failure to meet the recovery time objective and the recovery point objective goals? So the first thing that we like to stress is failure points, understanding failure points. This can be done through a technique called failure mode analysis, where basically what you're doing is you're thinking through all the scenarios that the application supports, and you're thinking through what are all the possible failure points. That can be the application itself, that can be infrastructure, that can be network, that can be basically any dependency that the application may have. And to determine which are critical and which are not is also very important. Critical in this sense means that if the failure occurs, then your application goes completely out. Non-critical means that there's some sort of mitigation where perhaps you might experience some performance degradation, which is not desirable, but it is not as bad as just being completely out. It is important to understand this because we have a finite set of time and resources with which to design and invest in our system. So we want to understand which ones are critical and which are not, and what's the probability and impact of that failure so that we can figure out what is the right recovery scenario and right recovery strategy and procedure to use for that particular failure. The stages of recovery are really important to understand. It is often seen that for certain failures, there is a partial restoration with a full restoration afterward, depending on the complexity of the data layer. As you work through these failure scenarios and these recovery scenarios, you'll find yourself figuring out what are your strategy and procedures. So for example, what is your failover strategy? Do you have a single region strategy, a multi-region strategy, and how does that affect your failover strategy? And most importantly for the strategies, it's not enough to just think through it. You really want to also make sure you test these failure scenarios as much as you can so that you can really test all of your assumptions and tune your procedures based on the learnings that you have from your testing. So when we apply the recovery lens to our simple system, we find that our highly available application is further augmented to support recovery. And here, let me walk through this. In the middle, we have our highly available resilient system. On the left-hand side, we see that from a recovery perspective, we may need to redeploy our application and its infrastructure. To do that, we want to add design time automation. AWS offers a number of services for this, for example, code commit, code deploy for source code management and deployment respectively, and CloudFormation for infrastructure as code. We also need to understand for certain strategies like failover, when we need to actually induce a failover. For that, it's very helpful to have telemetry, which are events, logs, metrics, traces, that give us the observability that we need to inspect our system and understand its behavior. AWS also offers a number of services to output telemetry, for example, CloudWatch and X-Ray for tracing. And there's also something called the personal health dashboard that gives us some insights into things like the API limits. We then also ideally want to have end-to-end recovery. What that means is specifically automated end-to-end recovery. That gives us the fastest time to recover. versus relying on human intervention. AWS allows a number of services for that as well. For example, SNS and Lambda for self-healing, if you wish to use it for that purpose. It's also worth noting, though, that the simple form of checklist is very useful because when we talk about procedures, it's helpful to write them down so that humans can easily follow those checklists. And from an automation perspective, if you write it as a procedure, you can also automate the runbooks that go with your recovery scenarios. And again, all of this should be tested as part of your resiliency and recovery strategy. So now we have a system that's highly available and can quickly recover. We need to now apply the reliability lens to make sure that we have stability over time. As mentioned before, we can quantify the goal of reliability with an SLO. That will balance investment with the expected user need. And we also want to use SLOs to understand the various user journeys or scenarios that the application is supporting. From a security perspective, a security lens comes into the picture for reliability as well, because we definitely do not want to experience failures from a security perspective. From a performance perspective, that's another common thing that we need to understand from a reliability perspective. What are the performance requirements? Are resources sized properly? Has testing occurred? And then finally, we talked about balancing the right level of investment for the expected user need. So we want to make sure that from a cost perspective, we're doing the right thing to make sure that our architecture is still cost efficient. So with that, we see that our system is now augmented further to support reliability. From a cost optimization perspective, AWS gives us certain services that are helpful, such as cost and usage reports that allow us to monitor costs over time and make adjustments. From a security perspective, there's a number of services that AWS offers as well that help us better understand our security posture, such as IAM and KMS and CloudTrail for API logs. So where Capital One is today, as mentioned, we are all in on the cloud, particularly AWS. We are steadily incorporating SRE, and we are continuing to mature how we apply resiliency, recoverability, and reliability. It's a journey. It certainly doesn't happen overnight, and we're still on that journey. And areas of focus include better understanding of our data layer patterns, better understanding of dependency management, and better application of architecture principles as outlined today for observability and stability. With that, I will go ahead and close and just share with you that if you want to learn more about Capital One, you can please feel free to check out Capital One Tech and Capital One Careers if you're interested in understanding what Capital One looks like as a career for you. Thank you so much.